Good afternoon. Today we will discuss the topic forecasting using regression. It's a part of predictive analytics, and we will discuss some cases related to operations and supply chain analytics. So let's start with the session. As you can see, forecasting in operation and supply chain management is a key area, and using forecasting you predict the future value, and it's a vital function. If somebody asks me as a business executive what is one of the key areas that I want a business or MBA or a BBA student to be proficient in, then I will definitely say forecasting is one area that he should have knowledge, and knowledge of any forecasting tool, so that he can come with a forecast will be one of the key essentials skill set that I look forward to in a particular executive or a student. Financial and accounting use forecast as a basis for budgeting and cost control. And marketing, the forecasts are used for new product introduction, planning the new product, or hiring the manpower. In production, we use forecast to select suppliers, determine future capacity requirements, and it helps to drive the decisions regarding purchasing of raw material or semi-finished inventory, staffing, and also to predict the warehousing inventory that need to be in place. So I think it's very useful business feature that one should be knowing about. There are four type of forecast. First is a qualitative forecast, and in qualitative forecast we we use different qualitative technique like expert opinion or brainstorming to come up with the forecast about the future scenario. Normally it's used when there is no precedents available or there is no data available, then we will go for qualitative survey based method or expert opinions or brainstorming to come up with the forecast for the future. But when the previous data is available, then we normally go for time series analysis or causal relationships and simulation. So when we look at specifically when we are looking at time series analysis, then we have several techniques that we talk about. More major one is the regression technique, and regression is also a common technique that is used in the causal relationship. And of course the simulation, sometime when the random numbers are some of one of the independent variable that can affect the forecast is random or unpredictable, it can take any value, then we use simulation techniques. And today our main focus is time series analysis, and this a version of it can be used in causal relationship that will go when we discuss about the regression, we will look at that. Time series is based on the idea that data relating to the past can be used to predict the future demand. So normally when we do time series analysis, that is a data time series, then short term means normally forecast in the 3 months used for tactical decisions. Then there is Medium term, these are 3 months to 2 years. It also captures the seasonal effects like summer, winter, or spring. A few things, there are a lot of demand like for woolen since winters, and like for swimming pool costume, there's a lot of demand during the summers. So all these seasonal effects are captured in medium term, 3 months to 2 years time period. And normally when we talk about long term forecast longer than 2 years, then we normally a lot of trends and cycles, a major turning point which are called cycles, they are also covered in long term forecast. So what are the factors that affect forecasting model selection? So when we discuss the what model to choose, like its time horizon to be forecast, is the data available or not? So if there's no numeric data available, no precedence, then of course we go for qualitative technique. But if data available is very short term, then we go for uh, limited short term forecast. And then accuracy, how much is the accuracy required, and the size of the forecasting budget, and also the availability of the qualified personnel. So if we have a lot of budget available, a lot of qualified personnel, then we can have sophisticated forecast, and we can always go for more accuracy. But if there's a low budget is available, time also is short, then we can forego a little bit of accuracy in terms of to meet the time requirement. So these are the consideration while we choose the what forecasting model that we come up with and we take into consideration. So now we look into linear regression technique. Linear regression is a statistical method that allows users to summarize and study relationship between a dependent variable and one or more independent variable. So in regression, basically what we say, there's a dependent variable y, and how to come up with the y which is a dependent, it is dependent on independent variable called x, and the value of y is a function of independent variable. And it is important to keep in mind that variables can have different scales. So while there's another presentation when we talk about different type of data, so normally when we deal in our general life, when we deal with the ratio or scale data, but sometimes we have data in categories that is ordinal, or sometimes it can be also yes or no type, then it is a nominal. So these variable can have different scale. But for linear regression technique that we use in forecasting, we have to make sure the dependent variable is a ratio, and the independent variable can be combination of different number types. If we look at mathematically, then we can say that we can easily say that y is a function of x, and it has a coefficient called beta 1, and of course there is a constant term called beta 0. But we cannot always forecast with accuracy, so always there is some error, and that error actually between the forecasted value and the, and the actual value, there is always a difference, and that error can be denoted by this term. And if we put this term, then of course the value will be denoted by y will be denoted by beta 0 plus beta 1 plus psi 1. Because a linear regression model is not always appropriate for the data, and then we should always look assess the appropriateness of model by defining residuals. So this is residuals are actually quite important. We'll come back to it when we do goodness of fit for the regression model. And what is residual is basically a difference between the observed value of the dependent variable and the predicted or the forecasted value. And if we were to say y is equal to beta 0, sorry, either beta, if you write b0 or b1, then error is always denoted by the value observed value minus the beta 0, the constant, and the beta 1, that is the regression coefficient, and the xi, the independent variable. And if we were to write beta, how to come out the beta 0, this is probably b0 or here. So b0 is equal to mean minus b1 x mean, and b1 can be predicted by xi minus mean yi minus observed value mean xi minus x mean square. And this is the way we can come up with this coefficient, and we can write, suppose there is one independent variable. If they are multiple, then it doesn't remain the simple linear regression, it becomes a multivariate linear regression. But if there is only single independent variable, it becomes the simple linear regression. Or this is the value that we can come up with, and this value is actually the y hat. And if we add an error term here, then it becomes the observed value. Without this, it always remains the forecasted value. And when we come up with the regression and we come with a forecasting model or a forecasting equation, so we normally say that how good is our regression model, that or the forecasting model we have come up. The fitness is how much variation in the dependent model how much variation in the dependent variable y that we can explain. And normally it is total sum of the square. Normally we'll say is the difference between the observed value and the mean, and square of that. And residual or the error sum square is the difference between the observed value and the predicted or forecasted value. And coefficient or determinants of good fit is normally we call it r square, that is coefficient of determination or goodness of fit, that is 1 minus residual sum square divided by total sum of square. So if the regression equation that you come up with for a forecasting model, if it has a high r square, then we say of course, yeah, that is the amount of variance in y that is explained by x is quite high. Normally we will expect this r square value to be at least more than 0.6. Few things that we have to take into consideration while we're doing in multiple regression rather than simple regression, then two or more variables. So we are talking about when there is a single independent variable x1, then we call it simple linear regression. And but sometimes there are multiple x1, x2, x3, multiple independent variable that can be used to predict or forecast the value of dependent variable y. So in such a scenario, when two or more variables are available in multiple regression, if they are highly correlated, then what we can your equation may have high r square, but the explanatory variables might fail the t-test. So normally you don't want high multicollinearity in your multiple regression model. Autocorrelation is a characteristic data when correlation between value of the same variable is based on related object. So normally in time series data, we face that the data itself is quite correlated to its own previous value. So we also don't want that. We all want autocorrelation to be low. Heterodiscity is when variability of variable is unequal across the range of values of second variable. Some like observe space, and we want to have variability of variance more or less equal around the range of values of the second variable that predict. And how do we normally go it? Like we look for scatter plots to identify the heterodiscity. So coming back to the main topic, let's that was a little bit of theory behind the regression. Now we'll talk about we come to simpler. I'll show you, demonstrate you how to do time series or regression based forecasting using Microsoft Excel. So just bear with me. Let's say y is a dependent variable or the forecasted variable, and a is of course the intercept constant, the y-intercept. B is the slope that we are saying coefficient. Beta 1 we say, or b1 we talk about that in previous slide. And of course t is the time, because the time series, the x1, the independent variable, is the time period. Let's look at this least square. We call it least square method, or which is a simple linear regression, because we want to reduce the errors as much as possible, error between the forecasted value and the actual value. So let's look at this example where we have time on the x-axis and the sales amount on the y-axis. So we look at quarter one, it is 3 months, quarter two, quarter three, quarter four, quarter five, and six, and sales have it's a 12 quarter. That means it is a 3 years data, and that sales is following a certain historical sales figures are given, and we want to know what will be the sales figure in the next period. So we can always do the manual calculation. We can find the average time period, and we can find the average value of the observed value, the historical values of the sales. We can find the average or the mean, and we can put the formula for a and b as we shown in the previous slide. We can calculate it and then manually calculate the forecasted value is equal to a, that is constant 441.67, plus b, that is the slope, right, or the coefficient, which is 359.6, and then x1, which is a t here. So this is something that can be found out, and using it we can always figure out that forecasted value. Suppose we can forecast using this equation. We put this is for 3 years. For the fourth year we can easily find out the forecasted value. Y is equal to a plus bt, and a and b value we have already in the previous slide we have calculated manually. But why don't we do it using the Excel? So easier is we can use Microsoft Excel, which everybody is has a knowledge, working knowledge, and they can easily use it to do the calculations. So let me go back to the Microsoft Excel and show you how to do the regression using Excel. So okay, so in the just I showed you we had this time series quarter 1 to quarter 12, 3 years, and the sales amount is given, and we can go to data analysis on the top the ribbon of the Microsoft Excel. You'll see a data analysis tab here. If this is not available, then what you can do here, this is an add-in. You can go to file, and then you can choose the options, and within options you have add-ins, and when you go to Excel add-ins, it will say analysis tool pack, visual basic, or euro currency tools, and solver add-in. So I have chosen, for example, I use solver add-in quite frequently. Analysis tool pack, I have chosen it, and I say okay here. And then within the data icon, you go to data tab, and within that you will see a data analysis. Okay, just click on it, and you will see within data analysis you will see many analysis tool like ANOVA, descriptive statistics, all Fourier analysis, histogram, moving average, sampling, t-test, z-test. So I choose regression because I'm for forecasting I'm using regression, and it will ask you for the input range. Why? What is the, so I put the historical this range here. Okay, and then it will ask me for the x. What is the x? So x for us is the previous time period. Yeah, so I put it here, and of course I click on labels because both of them, quarter and sales, the input range has labels, and of course constant is not 0. We are looking at 95% confidence level, and then I want whatever that, of course I choose residuals and standard residuals, and I click OK. So you'll see some results here. So it says R multiple R 0.966, R square that we're talking about is 90.93. It means that 93% of the variation in Y is explained by X. Correct? So this is something that we will be happily, we will be okay to use it. And you see here the coefficient 441.66 and 359.61. Yeah, so these are intercept, which is value of A and value of B. So these are the same value that we manually, while I giving you the PowerPoint presentation, I showed you this is something that we calculated manually there. But using Microsoft Excel, these things are calculated by the analysis tool pack for you. And these are the of course this is something that is given to you. Acha, what we also have to read is the significance level. So you can see this is almost in yeah, so this is less than 0.05. So we can definitely say that this we are our hypothesis that beta 1 equal to 0 doesn't stand. So beta 1 has a value, and how much is the value? It's given here. So so we reject our null hypothesis that beta is equal to 0. It is not 0, it is equal to this one. So a plus b, sorry, beta or b, I am using the term interchangeably. So if you go back to PowerPoint, you can see these are the same value that we calculated here. B is equal to 359, a is equal to, and our equation become y equal to 441.359.6 t. Yeah. Now let me give you some more examples. Let's say we have one more. Rather than time series, we have some other constant also available with us, and we rather than time series, it is sales will depend on number of housing permits. So suppose this could be another thing, that rather than time period, you want to take something else as your uh, independent variable. So for that, we again go to regression analysis. Okay, so I choose my input, which is sales. Then I choose my x1. So let's see if I'm able to. Yeah, confidence labels are there. New worksheet. I say okay. So you can again see that I have a r square which is given here. R square is 98. So I am able to, the variance in y is explained by variance in x, or we can, sales will also depend, rather than depending on time period, can also depend on number of housing permit starts. And this is shown here, and intercept in this case constant is 6698 and number is 344. So we can say that sales, housing sales equal to 6698.5 plus 344.2 multiplied by number of housing start permits, number of permits that are given in that particular year. So that will also be able to, rather than time period, some other independent variable is used to forecast the sales. So that is one example, and you can have multiple variables as well. So sales can as well depend on housing permit start as well as the year. So that is a part of multiple regression that I talked about. And when you have simple linear regression, then only one x is there and one y is there. But if you have two x1 and x2, suppose these are two x1 and x2, it's become multiple linear regression. And sometimes these relationship between y and x, y is equal to a plus bx plus c x square. So sometimes relationship is not linear, then it becomes non-linear, multiple non-linear regression. So those things can be also used to do forecast. So here is a very simple technique that I shared with you that can be used to do forecasting, and time series we just discussed just right now. Causal is when rather than time you use x1 and x2. For example, it is number of housing permit starts and the population in that year. So population in the area, population density in that area for that particular year. So x1 x2 rather than time they become some other nature of variables are different, then causal relationship can be used to do a regression model of forecasting. And when one of the variable is random, then simulation technique is used. If such data is not available, historical data is now not available, or precedence is not available, we go for qualitative techniques. So here is a simple presentation on forecasting and how it is used in production and operations and supply chain analytics. And hopefully you have good idea about this topic and you will use it in your subject. Thank you very much.